Hello and welcome back to the channel. This is a new video on how I implemented WebSockets in Payload CMS. So first I'll just demo the application. I'll include the link below, but this is the original to-do project that I created it's just a Next.js application connected to Payload that allows you to enter to-dos and associate images. And what I've done now is I've added this new page called To Do Live. So what this does is this is connected to the WebSockets to get live updates on pages. So I have the app open here in, what is this? This is Edge. I have that app open here in Safari, and we're gonna show how we get live updates across all of the instances of the application by modifying collections inside a payload, and then we'll kind of walk through the code to show how I implement it. I'm not saying this is the best implementation or the only implementation, it's how I implemented it. So first let's start with something simple. We'll just edit this first one. One more time live update for video. One more time live, we'll just change one so we can get the update. And you can see that both of them updated. Let's make a new one. So let's go back to to-dos, create new to-do, new demo to-do, something. And let's associate a media file with it. All right. This is to-do image, save. And then, so the media is now created. And then now let's save my to-do. And you can see it immediately appeared here and it immediately appeared there. And then the last one is just delete. So let's just pick one of these guys and delete it. So let's new to-do with image. Let's confirm, delete, and now it's gone. So we saw the updates happening real time on all of the hosts that were connected. All right, now let's take a look at how I actually implemented this thing. All right, so first let's take a look at the project structure. It's a straightforward project structure where we have the grouping for my front-end application, and we have the grouping for the payload application. So what changes were made? So if we look at the structure, let's start right at the top. So I had to, let me make this bigger. So the first thing is I wrote a plugin, and it's called WebSocket Server Plugin. It takes so these are the collections that you want to listen to changes on. So you can pass in an array of collections. And then there's another parameter, which I believe is port, and you can specify what port you want to listen on for the WebSocket server. It defaults to 8081, but you can pass another value if you want to. That is how you set this thing up. So let's take a look at the actual source code for my plugin. So let's go into plugin, and okay, so this file was created from the default plugin template for Payload CMS. I'm going to focus on just the things that I made changes to, since the rest is included in the default template. So here I set up my types. So these are for the parameters that can be passed in. I have my port number, and then I have my collection. All right, I have my global, and also I've commented it pretty well. I have a global WebSocket server instance that's set up. All right, so we have our plugin options set up here. We have the incoming configuration. This is a default configuration for the entire application. And then if there's collections in the plugin options, here's where we kind of loop through them and start to manage how we're going to interact with the collections that have been passed into the parameters. And then we get the collections here that are going to be worked with. And ours should just be to-dos. So now this is just passing all the config information back to the systems, because if you come down to the bottom, I jump ahead, you'll see that it's just returning a configuration object. So it's appending all the stuff that we're adding in this plugin to the overall configuration object. So let's go back up to where we were and focus on what we're trying to do. What we're trying to do is hook in, for lack of a better word, hook into our collections through the hooks. And the two hooks we're going to focus on are the after delete. So basically after a user deletes an object from a collection, and then after any change in the collection, because we want to focus on the CRUD actions. So the after change will get us to create the read and the update, and the after delete will get us the delete message. So now if you look at the code, you can see that basically what this hook will do is it will connect onto the collection that was passed in a new hook for after delete. In the after delete, we get past the document. If I have my instance of my WebSocket server that we initialized up here, then I'm going to create a message to indicate that the collection changed. I'll pass the slug of the collection in, I'll pass the operation, and I'll pass the document that I got passed into the hook. And then I'll iterate through each client, make sure that it's ready, and I will send the message. The message is this JSON object, and this object will be received to all listeners. The pattern for create and for read and for update is the exact same. A little bit more, code you have to do to handle the different scenarios. One thing that I thought was obvious was that I would just be able to just follow the same pattern as above and just take the doc and pass it through. But because we have a relationship between the media object and the actual document, when you get this document passed in here, you only get the ID for the media. I didn't dig deeper. There's probably another way around it, but for now, all I'm doing is I'm taking a document ID that I get passed in on this operation. I'm querying that object, updating the depth to make sure I get the whole media object, and then I'm passing that document that I just created, that document that I just fetched. And as I'm looking at this even more, I probably could change this to find by ID to make this easier, but this works. So I get the populated doc, I take the first instance of it, also probably should check to see if I actually have a document, but this is not final production code. I'm just trying to show a concept. So we get the document, we have a new message type called collection change, we pass the slug, we pass the operation because here it could be many different things, not just delete. We set up the message, and then inside of here, we follow the same pattern as above. We loop through all of the clients that have been connected, and we send the message to all of them. And then we just return the doc. All right, and then now let's look and see what this does on initialize. So on init of this plugin, it initializes the WebSocket server when payload starts, sets a message handling for collection and data requests. All right, so this is where we're creating that WebSocket server instance that we referenced above. And then this is where we're looping through, because on initialization, when we first start up, we want to fetch the whole collection. I'm not dealing with paging or any other stuff, and just send everything over. I'm taking the data limit that got passed in from the initial message, and we'll look at that on the client side. And then we do a fetch on payload on the specific collection that was passed in, depth of 2 to make sure we get anything, basically the first level of relationships, and we get the results. And then we package up the results just like we did in the other situations above, right? So we are just going to create an object. And this one's pretty simple because we know on a fetch collection, the message we send back is the collection data, and we just pass back the results of that collection. And that's pretty much all we do here inside of our WebSocket server. So let's move over to the app now. And we are going to start. There were no specific changes that need to be made on Payload. Most of the changes were made in the front end app to support the To-Do Live page. So let's talk about how we got this to work. All right, this is our To-Do Live page. This is the page that you see right here that's rendered, and I'll kind of walk through how we got it to work. So let's first cover some of the supporting files. So first, here's a types and constants file that was created that has the default configuration information that we need. So we have the URL we're connecting to, the max number of retries, and retry delay. This information probably should be moved into a .env file and then set inside of here. Here's the message types that we support. We fetch the whole collection. We get collection data, and on collection change, here's status constants that we're using. And then here's just the type, the to-do type that we're passing back through. The type for the actual message that we're getting passed. So it's going to have the type string for one of those above. It's going to have the name of the collection, and then a specific operation, and then the package, the payload, which would be the to-do object. And then here's the types for the connection status. That's the types that we're going to see inside of here. And then as for the hook, we'll talk about the hook when we get to the hook. Okay, so now that we've covered all the types and constants, let's look at how this page is actually structured. All right, so we can see up at the top here, we set up our array that's going to hold all the to-dos. This is the callback handler. I'll jump back to that. But the way that we could get this whole thing going is through this use WebSockets hook that's created. It gets passed a message type. Well, the message type gets associated with it, and then it returns a status. We pass in the collections that we want, and then we pass in how we want to handle the message when we get a message back from the server. So let's hop into it, and then we'll go back up to our handle message. So let's go to our use WebSocket hook. All right, so this use WebSocket hook is set up to allow you to use it for multiple collections. So I had it embedded in the page, but then I kind of extracted it out into this separate use component. And let's kind of walk through what's happening here. So here we keep track of what the status is. And so when it first starts up, its connection status is going to be set to connecting. It's creating a ref that we're going to keep the actual connection once we do get it set in. And then everything's in this use effect hook. We're using the use effect hook so that at startup, we can spin up our connection. And then we have the ability at the end, when this component goes away, to kind of clean up our connection and shut everything down. All right. So, and also we have our retry. You saw that in the types, we try 5 times to connect. So here we're just keeping track of the first count. Inside this use effect, we call connect WebSocket. And then here's what connect WebSocket does. This is basic WebSocket connection code. Nothing magical here, except for this. So this was one of the first challenges that I ran into, which was that plugins get initialized when the admin console gets initialized. And so you can't assume that the admin console is going to be initialized whenever you want to use your application. So I needed a way to initialize Payload to force it to load my plugin when the application needed it done. So I've created this server action called init payload that, let's go take a look at that. So this is a server action that basically just initializes payload. So if the application hasn't initialized payload yet, then it will initialize payload. All it needs to do is get the configuration, call get payload. That's it. That call in itself will trigger payload to load its plugins. The plugin will load. The plugin will open up the WebSocket server. It will connect itself to the collections that it needed to be connected to, and then the application will be able to get the updates that it needs. So that's what a payload does, and that's a server action. So that server action gets called from this client component at startup to make sure that the WebSocket server is up and running. And once that comes back, then we take our configuration URL, which is the server we just started, and we basically get our reference to it. And then we listen for our onOpen. Once we get our connection status, we send our initial fetch message to get all the data for the first, to get all of the data for the collection that's associated with this application. That's what the onOpen does. The onMessage gets called when we, i.e. the client, receives a message. We take the message data that got sent to us, and then we call onMessage. OnMessage got passed in right here. The 2 things we got passed in was onMessage and the collection. The onMessage gets passed in, and that's the handler that we'll circle back around to. And so we're basically sending the message that we got to that handler through that callback. All of these are handlers that we're going to get from our WebSocket connection. So as we already covered, the onOpen, the onMessage, and then the onClose. So basically when the WebSocket server is shutting down, we're going to get this onClose, and then we need to kind of clean up everything on our side down here. Here's where we catch error messages, and we just set the status on the hook based on the error message. And as I said in the beginning, this is how we start everything up, and this is how we clean everything up. And then the hook is dependent on changes of the collection object and the onMessage object. And then we just return a status from here. So that's how the WebSocket hook works. And then we got to circle back and talk about how this onMessage actually works in the page. And so we're back here. And as you can see, the onMessage is this handle message call. Handle message takes the message that we received from the WebSocket server. We identify the type, then based on the type, we handle it. So if it's the initial collection data message type, we're basically getting the whole collection and we're just passing it in. If it's a collection change, and because right now we're just focusing on to-dos here, so we definitely need to check the collection type, then we identify the operation, whether it's a create, an update, or delete. We do the appropriate state management change to update. So on create, we're just going to append a new item to our array of to-dos so it can be rendered below. On update, we're going to find the item that got updated and we're going to assign it to the new message doc as opposed to what its value was originally. And on delete, we're just going to take the ID that we got passed it on the message doc and we're just going to remove it from the list of to-dos. And all that stuff's pretty straightforward. And then we just come down here to the UI. You can see we do keep track of the connection status up here. So you can see if it's green when it's connected and red when we're not connected. And then this code for looping through the to-dos. So of course, every time the to-do object gets updated by any change, because React's reactive, it will re-render this list. And so that's how we get the live updates. I think that's pretty much it. Like I said, most of my challenge was first getting the plugin working effectively. And then after I got the plugin working effectively, I got stumped because I wasn't always opening up my admin tool. And because I wasn't opening up the admin tool or admin console, the WebSocket server wasn't starting up. So I wasn't getting any live updates. Then it took me a while to realize that problem was, and then I had to find a creative way to initialize the plugin at startup. Because I didn't want to just completely decouple the WebSocket server from Payload, which is something that I could have done, and then tried to figure out how to get access to Payload again inside of my WebSocket server. I thought that just would be way too complicated. So the best approach was to me, for where I am, and maybe someone who knows the architecture better than I do of how Payload works, maybe there is a way to do it without this separate init payload action. And maybe there is some way to get I don't know how it could be, but some way to get the plugins to start up. I don't know. But that's beyond my experience with Payload. My focus really was on trying to figure out if there was a way to integrate WebSocket server inside of Payload to get this kind of real-time activity. You can also see I do have another video, which I'll link below, where I used I actually forget the name of the technology that I used. It was a web standard that's available without any additional libraries, where I was able to do something similar to this. I don't believe it's as robust as having a separate standalone server and all these other things, but it's just another solution that I'll show. So thanks for stopping by. Hopefully you found some value out of this. Happy to get your feedback and thoughts on it. Thanks again, and I will talk to you later.